In example 4, we need to prove a couple triangles here are congruent, and we're given some information that may help us on the road to doing that. So let's go ahead and write our given information down first. AE bisects BD, and we'll make a conclusion about that here shortly, but really nothing to mark here on the diagram. And we're also told that AB is parallel to DE. A little long on the line there, but we'll go with it. So AB is parallel to DE, and we've got those parallel marks here, the little arrowheads. Let's make a conclusion based on one of these previous statements. Let's look at AE bisecting BD. Well, if AE bisects BD, it's going to break BD into two congruent pieces. So we could make the statement that BC here would be congruent to CD. And that's just the definition of a bisector, or what it means to bisect. Let's use AB parallel to DE. AB parallel to DE. We could state here that angle B is congruent to angle D. So here are your parallel lines. Here's your transversal. These angles are on alternate sides of the transversal, but on the interior or on the inside of the parallel lines. So we could say here that angle B is congruent to angle D. The reason would be that alternate interior angles are congruent. We're getting closer here. We've got angle side, but we need to have three and in a specific order. So let's see if we can make a statement here about angle angle ACB and DCE. And we can actually make the statement that those are congruent. So we'll write angle ACB congruent to DCE. And the reason here is going to be vertical angles are congruent. Those two angles are non-adjacent and formed by two intersecting lines, so they must be vertical angles. We can now work with our proof statement here. Triangle ACB is congruent to ECD, and the reason here is angle side angle, angle side angle.